Hey there, Dean Drivers. Today, we're diving into something really quite groundbreaking. It's about water out in space, and it's all thanks to the incredible James Webb Space Telescope. And this isn't just, a neat little fact. It's actually a huge piece of the puzzle for figuring out where planets get their water, which of course is essential for life, and really changes how we search for habitable worlds.
Exactly. And for this depth dive, we're looking closely at sources like cosmic ice. Webb finds water around young star. Because what these Webb observations are showing us is it's kind of fundamentally shifting our models, how planets actually gather material, and even, our cosmic origins.
Right.
We're connecting the dots here between new data and old theories.
Okay, so let's get to the core finding. The Webb telescope has found water ice. But not just any water ice. It's in crystalline form, right? For the first time in a dust disk around a young star. Now, crystalline. That means structured ice, like ice cubes, basically, not just messy, amorphous ice. And the star itself, pretty similar to our sun. So, okay, unpack this for us. What does this actually tell?
Well, yeah, the context is key. The star is HD 888327. It's about 155 light years away. And it's young, really young, astronomically speaking, just 23 million years old. So it's actively building planets right now. And how they found it, they used Webb's near-infrared spectrograph. NIR spec, which is just incredibly powerful. It basically lets them see the chemical fingerprint of the water, how it absorbs specific light.
Right, the signature. But what really jumped out at me was the amount and where it is, this water ice. It's like heavily concentrated way out in the system's outer belt, making up over 20% of the total mass out there. That's huge. It sounds a lot like, the Kuiper Belt in our own solar system, those dirty snowballs. That concentration in the outer part, that's really important, isn't it? Tells us where the water starts out.
Yeah. Precisely. Yeah, that's the reservoir. And it's such a stark contrast to the inner parts of the system, closer to the star. Almost no water ice detected. And this pattern, it lines up perfectly with what we'd expect based on the conditions. Two main reasons likely for that inner dryness. Either the star's strong UV radiation just vaporized the ice, sublimated it straight to gas, or it got locked up very quickly into rocky bodies, planetesimals.
The building blocks.
Exactly, the things that eventually smash together to form planets. So you get rock foundations inside, water reserves outside, sort of.
And the really amazing thing here, this isn't just a new discovery out of the blue. It actually confirms theories scientists were proposing, 25 years ago?
Yeah, at least.
For decades, the models suggested this icy stuff forming far out, maybe getting delivered inwards later, but actually seeing that crystalline ice distribution, that's been missing. So what does this confirmation, this sort of observational proof, really mean for those models?
Well, it strengthens them immensely. A huge validation. We've relied so much on simulations, indirect clues. This is, Webb gave us the smoking gun. It's real, tangible evidence showing how water, life's key ingredient, right, gets spread around in these very early stages. And that directly feeds into understanding if exoplanets could be habitable. If water's common early on, especially stable crystalline ice, it just bumps up the odds, for life elsewhere.
Right.
And the fact that this work came out of Johns Hopkins, published in Nature, it just underlines how significant this is. It's a real turning point.
So bringing it all together, what's the big takeaway? Clearly, the Webb telescope is just phenomenal, showing us water is common in these young systems. And is providing that direct evidence, validating these long-held ideas about how planets get their water. It feels like we're literally watching the origin story of water on planets unfold, maybe even our own.
And that leads to, a pretty profound question, doesn't it? If water, this absolutely fundamental thing for life as we know it, is this abundant right from the start in systems like this, what does that really suggest about the probability, the sheer likelihood of life cropping up elsewhere? It shifts the thinking maybe from if life exists out there to more like how widespread and where.
That is definitely something to chew on. A fantastic thought to end on. Keep exploring this amazing universe with us. We'll keep diving deep into these big questions.